Flat plate collector test. We are right in front of a large flat plate collector. The cold water enters from the position below. By cold cycling, flow from this location. The outlet of the economizer is an automatic exhaust valve. The one on the top is the temperature sensor. This is an arrangement valve. This is a pressure sensor. When the pressure of our system is greater than 3 bar, the safety valve will operate and release the pressure. Then let's look at the front. This is the thermal radiation sensor. It shows the light intensity. Then we look at the front control box. This is our control box. This is a display screen, power supply, power indicator light. This is the switch for the pump. Our schematic is here. We have 2 water loops. One is that the cold water of the collector enters from the lower side and comes out from the upper side. There is a circulation loop for heat exchange through a flat plate heat exchanger. The following is the water circulation circuit of the water tank, also through our pumps. Cold water into hot air. The cold water is heated by a heat exchanger. Then came out hot water. Back in this tank. This is our tank. The lower side is a circulating rod for cold water. The upper side is a circulating rod of our collector. The expansion tank stabilizes the system at a constant pressure. Let's take a look here. This is a liquid ejection port. This is a drain. We can inject liquid from here. The system pressure must be greater than 2 bar. Only the water circulation loop of the collector can work. This is a drain. When our experiment is over, the water in the collector can be discharged from this port. Now we power up. We can see that the power indicator light is on. Then our touch screen is starting up. We can see that. Now the temperature on the upper side of the collector is 16.5 degrees Celsius. Now the system pressure is 2.23 bar. Now the light intensity is 0 because we put the lid on. Let's see the temperature of the water tank is 4.6 degrees Celsius. The temperature of each inlet and outlet of the heat exchanger can be displayed in real time. Also, we have flow sensor that shows the flow in both loops. Now our water pump is not on, so the current flow rate is 0 liter per minute. And then let's focus on this is the maximum set and the minimum value set. When the temperature in our collector is greater than a difference of more than 3 degrees from the temperature of the water tank, the pump will start working. At the same time, the water pump below will also start to operate, then do a water cycle. Then when the temperature difference between the upside collector and the temperature in the water tank is less than or equal to this minimum set value, both pumps stop working. Right now we are setting a maximum of 3 degrees Celsius. The minimum is 2 degrees Celsius. Now we see that the temperature in the collector is about 5.5 degrees Celsius higher than the temperature on the tank. So when it's greater than 3 degrees Celsius, we turn on the switch of this pump. We can hear the pumps start working now. Let's take a look at the current flow of the collector circuit at about 8 liters per minute. Then the flow rate of the cold water circuit is about 2.26 liters per minute. Then we can see that the heat transfer effect is obvious. The The temperature of the incoming water in our plate heat exchanger hot water circuit is 13 degrees Celsius. The water temperature is 12 degrees Celsius. The inlet water temperature of the cold water loop is 8.2 degrees Celsius. The water temperature is 12 degrees Celsius. This has a good heat exchange effect. The temperature of the collector on the opposite is gradually decreasing. The temperature in the tank is gradually increasing. When the temperature difference is less than or equal to 2 degrees Celsius, the water temperature will stop working.